Hi, Blue Team. So Rosie and I are ready to move on to our next part of our study of Earth history. And uh, so now that we've looked at fossils, given us evidence to how life has changed over the history of our planet, and also to how the Earth has changed. We then looked at how also we can figure out when these changes occurred in life and in our planet through radiometric dating. And now we can put all that together and say, okay, let's look at the history of our planet and when all this occurred and divide it up into divisions and so on when major changes have occurred. So, based on the evidence we have of the age of the oldest rocks we have ever found, the Earth is about a little over 4.5 billion years old. So we're going to take that a little over 4.5 billion years and divide it up. And we're going to divide it up based on, okay, when was there big changes in the Earth and the life that has lived on the Earth. So what led to those changes? Well, as we'll learn later, the continents and the land masses of our planet have constantly been in motion, and they've moved north, moved south, and that's going to cause different climates to form, and that's going to affect life. And we're going to see more sudden events like lots of volcanic activity or strikes from large meteors or asteroids from space that, upon their impact, really can disrupt the amount of sunlight getting through and those types of things. So when we look at the history of planet Earth, we're going to divide it up into major divisions, and those major divisions are going to be called eras. And though Jason looks at the first era, the Precambrian, as kind of like a series of eons, which are even larger divisions, we're going to look at the division of the Earth's history as 4 eras: the Precambrian, the Paleozoic, the Mesozoic, and the one we are currently living in, the Cenozoic. Now, there have been a lot of other changes that have occurred over time, and they've been significant, but not enough to say, hey, it's a new era. And keep in mind, this isn't like, hey, tomorrow is going to be a new era. These are very gradual changes. And remember, we're talking about billions and millions of years. So if there's some significant change in the major forms of life and in the planet, we're going to subdivide eras into what we call periods. Okay, and that's going to be the first thing you're going to put on your notes. So if you have your Google slide open, you're going to see that there is eras are the largest division of geologic time, and Rosie's going to show you what you should have for number 1. Those major subdivisions are going to be called periods. So for number 1, under letter A, eras, you're going to place the word periods, subdivisions of eras. Now, I want you to keep in mind that we are, as I said, in the Cenozoic era, which is 65 million years and counting since the dinosaurs went through their mass extinction. And we are also in the same period, the Quaternary, where woolly mammoths and mastodons and saber-toothed cats and the ice ages and all that have occurred. We're still in that same period, so you can imagine how much change must have to take place for there to be a new period, and really the amount of change that must occur for there to be a new era. And we're going to spend the rest of our time in this unit on Earth history talking about those. As I said, we're not going to talk about eons. We're not going to get into even subdivisions of periods, which are epochs and so on. But the 4 eras, Precambrian, Paleozoic, Mesozoic, and Cenozoic, and some of their periods. Okay, so first thing you should have written is the word periods. Okay, so we're going to make our way through the 4 eras, starting today with the Precambrian. And as I said earlier, Jason calls it Precambrian time and looks at it as a series of 3 eons, but we're going to look at it as the Precambrian era. It's over 4 billion years in length. So if you remember what I said earlier, that as far as we know, based on the evidence, the Earth's a little over 4.5 billion years old. So over 4 billion of that is the Precambrian era. So obviously it is the longest era. And there isn't any subdivision of it into periods. The other three eras will have subdivisions and divided further into periods, but not the Precambrian. Not because there wasn't a lot of change. The Earth went through tremendous change. But what didn't change that much was life. So that's going to be, one of the major factors when we divide all the other eras up is the emergence of different life forms and extinction of others and big, big changes in life. But in the Precambrian, we're not going to see that. The Earth is going to start out as we believe a molten planet. It's going to cool. Eventually, oceans are going to form. There is not going to be, for over 4 billion years, there is no fossil evidence of any life on land. When life does come about 3.8 billion years ago, it's going to be in the oceans. How those oceans formed is another question. Did comets bring some of the water? Was it from all the volcanic activity? There was tremendous amounts of volcanic activity. Did that lead to there being water in the atmosphere that eventually helped form the oceans? Because that's a lot of water. So that's still something scientists are trying to figure out. But needless to say, most of our planet is ocean now, and where all that water came from is still up for debate. So the planet is going to cool. And in those oceans, like I said, 3.8 billion years ago, as far as we know right now, we're going to see life. Now, is it going to be life like Rosie here? Absolutely not. Very, very simple life, microscopic life, that eventually we're going to see multicellular organisms, but they're going to be very simple. Things like sponges, like your friend SpongeBob, jellyfish, very, very simple organisms. They don't have brains. They don't have eyes. They are extremely simple. Okay. And we're going to see something called blue-green algae, which still exists today. It's a form of bacteria, actually. But what it does that is really, really important is it carries on photosynthesis and produces oxygen. So the first atmosphere of the Earth was nothing like today's. You're not going to have that oxygen that we all need to live. It was a pretty noxious mix that wouldn't have been very pleasant. But these blue-green algae start producing that oxygen that starts building up in the atmosphere. If you've ever been to Yellowstone National Park and you went to where there's some of those pools where there's multicolored material you see in the water, those are mats of bacteria. And this is what you would find in the Precambrian era. And they kind of have that sulfury smell and so on. But they are very similar to what we think it was like back in the Precambrian. Now, obviously, there weren't a lot of hard parts to any of these simple organisms, the bacteria, the sponges, the jellyfish, and so on. So we do have some fossil evidence. Some of the colonies of bacteria form what's called stromatolites, and you're going to see those on, I think it's slide 5. There's some fossilized remains of those. Okay, so anyways, I'd like you to have slide 3 open right now. You'll see Precambrian era. And what you're going to fill in there for letter B is it begins with the formation of the Earth and lasts over, and the words you're going to put in, Rosie, let's give it to them. It's going to last over 4 billion years. It is the longest of all the eras. 4 billion, over 4 billion. And as we said, life, we think about 3.8 billion, but it was very simple. Bacteria, algae, sponges, worms as well, not worms like you think of those things in the ground. There is nothing on land. It's barren rock. They are a different type of worms, very simple worms that lived in the floor of the ocean. Okay, and if you go through those slides, you'll see all the volcanic activity. You kind of get a look at the mats of bacteria, and like I said, fossilized remains are there on slide 5. Okay, so this is the Precambrian era. Okay, all right, so that's all you have to fill in for today. You can take a look at those other slides. Rosie? Yep, we are done for this one, and I'll see you guys next week. Hope you have a good weekend, and stay safe, and we'll talk to you soon.